Hello and welcome to another exciting math video. And in this video, we're going to start a new unit, chapter 4 in the book, covering trigonometry. And here are 8 sections. We're going to start this one today, radian and degree measures. And then we'll do, we're going to skip 4.2 right away. We'll go on to 4.3, right triangle trig, and then trig of any angles. And then we'll come back to 4.2, and then we'll do some graphing of them and find the inverses and this other stuff. Okay, so it's going to be an exciting unit on trigonometry if you've been bored with the algebra. And let's see here, it says trig is used to find relationships between the sides of triangles and to write trig functions that can model real-life quantities. And it says in real life, trig functions are used to model quantities that are periodic. For instance, throughout the day, the depth of the water at the end of the dock in Bar Harbor, Maine varies with the tides. The tide goes in and out, the water gets deeper and shallower, and we can model that using a trig function because it is periodic. In careers, biologists use little trig, meteorology, weather people, engineering, any kind of engineer is going to use some trig, and surveyors. If you've ever seen the road crews where there's a guy out maybe looking through something, looks kind of like a camera on a tripod, and there's another guy standing out there and he's holding up a stick or a flag or something. What they're doing is setting up and solving triangles to survey, new roads or railroad paths or whatever. Actually, a really neat job that uses a whole bunch of trig. And here we go. Radian and degree measure. You probably recognize the word degree because that's how you measured angles in geometry. So in the video, this video is the day 1 video. We're going to go over degree stuff. Day number 2, we will go over another way to measure angles called radians. And then in day 3, we'll do some real life applications. So a lot of stuff you're going to see today you might have seen before in geometry class, and there's probably one new thing you have not seen before. First, let's talk about an angle. An angle, of course, has a vertex where our two sides come together. In trig, we're going to distinguish between the side where the angle starts, so that will be this side here, the initial side, and then our angle is going to open up. We will denote that with an arrow showing the direction, and then that angle is going to stop on the terminal side. So initial side, our angle opens to the terminal side, and notice here we're opening counterclockwise. That means our angle is going to be positive. And if I move this over here, we are going to orient our angle in standard position. And standard position means our initial side will be the positive x-axis. From there, we will open up our angle to the terminal side. And again, I'm drawing this red arrow, denoting which way our angle opened. Okay, a little bit more here. If we open it up counterclockwise, our angle will be a positive angle. Now, you probably did not see negative angles in geometry class, but they are out there. And let me draw a new xy axis down here. A negative angle opens clockwise, so our initial side will always be the positive x-axis. But if our arrow would look like this, opening up this way, oops, get out of there, that is going to be a negative degree angle. I'll just call this maybe negative 40 degrees. Now here's something you probably haven't seen before, the idea of a coterminal angle. And coterminal angles, they have the same initial and the same terminal sides. Such angles are called coterminal. Now there's a couple varieties here. I'm just sort of going to redraw the graph in the middle, like right here. Let's say I have my initial side is positive x-axis, and my terminal side is going to end here. So this would be a positive angle, some positive number of degrees. And another way I can get from the same initial side to the same terminal side, I'm going to start here on the same initial, but go this way. So this would be a negative angle, but they do have the same initial side, they have the same terminal side, so those angles would be coterminal, one positive and one negative. Now another type of coterminal angle, notice when I drew this red arrow, I just opened it up that much. I went from my initial side to my terminal side. Well, what if I went like this? I'm going to start on my same initial, but I'm not going to stop here. I'm going to do another lap around, and then I'm going to stop. See, we did an extra spin around the circle, but we did have the same initial side. We did stop on the same terminal side, so that would also be a coterminal angle. Let's look more at the graph provided by the book. Oops, let me just make this a little bit bigger. And we'll get that out of there. Okay. So here, this angle, that's the Greek letter alpha. Kind of looks like a little fish. So here is angle alpha. It's a real short angle. It starts on the initial and ends on the terminal. And then this is Greek letter beta. Angle beta also started here on the same initial side, but we went all the way around, did another lap around before we stopped at the terminal side. So angles alpha and beta are going to be coterminal angles. Now, a couple more things about orienting our circle here in the Cartesian plane. So if our standard position, we always start on the positive x-axis, as we start to go counterclockwise around the circle, we can fill in some angles. Of course, a full 60 is, or a full circle is 360, and if we go halfway around the circle, that's 180. And you probably remember from geometry that right angles are 90 degrees. So as we open up from here, the initial side, if we go to the positive y-axis, that's a 90-degree angle. If we continue on to the negative x-axis, that's 180 degrees. We continue our trip around down here to the negative y-axis, that's 270. And then if we keep going around, we get back to 360. So we started at 0, we went all the way around, and we stopped at 360, so that's a full circle, or 360 degrees. Notice here, let's at least focus on the first quadrant, we've got three angles within the first quadrant, 30 degrees, 45 degrees, and 60 degrees. And those are also going to translate into our other quadrants. We're always going to have between our right angles these three more angles inside each quadrant. So again, if you want to count by 90s, we're going 0 degrees, 90 degrees, 180, 270, 360, and we've gone all the way around the circle. So here, any angle between 0 and 90 winds up in quad 1. Any angle from 90 to 180 is in quad 2. Anything from 180 to 270 is in the third quadrant, and 270 to 360 is in the fourth quadrant. All right, a couple more things you might remember from geometry. Some types of angles. We have acute. Acute angles are less than right, so 0 to 90 degrees. If it is perfectly a right angle, as 90 degrees, or we could think about it as 1/4 of a revolution, a quarter of the way around the circle. If we open it up a little bit more, between 90 and 180, that is obtuse. If it is a straight line, you notice the way this angle is opening up, that is a straight angle, or 180 degrees, or half of a revolution. Now this last one, if I just drew this, that just kind of looks like a line segment. But then if I draw the angle that the arrow that the angle opens up, here I would start at the positive x and go all the way around. Now we can see that's an angle. It's 360 degrees, or a full revolution, a full trip around the circle. Okay, example 1, we're finally going to get to do some stuff here. The directions, sketch and find coterminal angles. First, it says here for the positive angle 390. So let's sketch 390. Well, I'm starting here on my positive x-axis, and I got to get to 390. So that's more than a full circle, so I know I'm going to go all the way around and do a full 360, but how many more degrees do I have to go? Well, we could do this. 390 minus 360 is equal to positive 30. So, we've gone a full lap around, a full 360. We're going to go another 30 degrees, and here's our terminal side. So the 390-degree angle is coterminal with the 30-degree angle. You know, they both start on the same initial side, they both end on the same terminal side. Now, the directions didn't say find more than one, but you know, we found this positive coterminal. Let's find a negative. If I take this 30 and subtract another 360, that's going to take me to negative 330. I'll keep my pen in blue ink, so if I start here on the same initial side and I go clockwise, if I go around this way, that is negative 330. So we went in the opposite direction and we ended on that same terminal side. So our coterminal angle could also be negative 330. Letter B. Angle is 135. Well, let's see if I start here at 0 and I go to 90, I'm not there yet. If I go to 180, I've gone too far. So I know I'm going to be somewhere here in the second quadrant. We're actually going to be splitting it right down the middle. So if I finish that arrow off, we went from the initial side to the terminal side. There is 135 degrees. So the easy way to find coterminals, and this is a great example to use this one on, if I want to find a positive coterminal, I'm going to take the angle they gave me and add another 360. 135 plus 360, that looks like 495. So if I were to draw a 495-degree angle, I'm going to switch to blue ink for this. I would start on the same initial. I'm not going to stop on the terminal yet. I still got to do another lap around the circle. And I go all the way around, and now I end on the same terminal side. So the red angle that I drew here is 135. The blue one is 495 because it did that extra lap around the circle. Now let's find a negative coterminal. I'm going to switch to black ink. Again, our starting angle was 135 and we added 360 to get a positive coterminal. Here, if we subtract 360, we're going to get a negative coterminal. So let's see, for this one, 135 minus 360 takes us to negative 225. So using my black ink, I'm here on the initial side, and we're going to go in the clockwise direction for a negative angle, and we stop at the same terminal side. That angle is negative 225. So there we sketched the original, and we did one of each, a positive and a negative coterminal. Now our last one starts us with a negative coterminal. Now be careful when we're graphing this one. I'm going to go clockwise and count by 90s. So if I go this way, this would be negative 90. And if I do another quadrant, that would be negative 180. So I've gone too far. We want negative 120. So let's see here. This would be negative 90. And then we're going to go another 30 degrees. So that's going to put us right here. And that is our negative 120. Okay, if we're at negative 120, let's find our positive coterminal. We're at negative 120, and we want to get to positive, so let's add a full circle 360. Negative 120 plus 360 is positive 240. So if we want to draw a positive coterminal, I'll stick with the black ink. If we want to do a positive angle, here we are at our initial side, and we're going to open it up counterclockwise, and we're going to stop on the same terminal side. So the red angle again is negative 120, and that is coterminal with positive 240. Now, since they gave us a negative to start, let's find a negative coterminal. Negative 120, let's subtract a full circle 360. So if we subtract negative 120 minus 360, that's negative 480. So to draw that one, I'm going to switch to blue ink. Here we are back on the initial side, and we're going to go here, but we're not going to stop. Oop, that's pretty terrible. Let me do it a little farther out here. So here's negative 120, but we're going to do another lap around and end on that same terminal side. So we just did an extra lap in the negative direction. That took us to negative 480. So coterminal Well, let me point this out. For the first one, they gave us a positive number that was pretty big to get started. So if you're more than a circle, here's 390, we could subtract a circle right away, and that takes us to 30. So there's our positive coterminal. And then if we subtract another 360, that takes us to our negative 330 for a negative coterminal. Okay, so just add and subtract circles until you get a positive and a negative answer. Now a little fill in the blank here. Two positive angles, alpha and beta, are blank if they add up to 90. Well, that's complementary. Complementary. That's supposed to be an E. I got a little glit. There we go. Complementary angles add up to 90. Two positive angles are blank if they sum up to 180. Well, that's supplementary. Supplementary. And here they are drawn in the first quadrant. So for the first one, alpha plus beta add up to 90. And for over here, supplements, that would be alpha plus beta add up to 180 degrees. So if they give you an angle, or let's do it this way, if you want to find a complement, take 90 minus the given angle. 90 minus the angle they gave you. If you want to find a supplement, it's 180 minus the angle that was given. And let me stress here in the definition, it is two positive angles, two positive angles. Complements and supplements are never with a negative. You can't have a negative for a complement or a supplement by definition, because complements and supplements are positive angles, or it's two positive angles that add up to those. So here for example 2, that's a two-parter. We've got A and B. So I'll do A in red. A. Given angle is 72 degrees. Find the comp and supplement if possible. So for 72, our complement is going to be 90 degrees minus 72 degrees, which is 18 degrees. 18 and 72 are complements. Let's find the supplements. That would be 180 minus the given angle. 180 minus 72 is 108. 108 degrees is our supplement. 108 and 72 are supplementary angles. Now I'm going to switch to blue ink for part B. They just give us a different angle, 148. So for B, the complement is going to be 90 minus 148, and it looks like we're going to run into trouble, because if we subtract that, we're going to get a negative answer. And remember, complements and supplements must be positive, so here we're going to write no complement. That angle does not have a complementary angle. But let's find the supplement of 148. So the supplement is going to be 180 degrees minus 148. And if we subtract that, it looks like it's a 32 degree supplement. Okay. Now this one, well, this you're just going to have to copy off the video. In class, we're going to do this on our TI-30s. It says here, you might not have seen this before, angles are measured in degrees, but each degree can be further divided into minutes and into seconds. Just like reading a clock. Every hour has 60 minutes, every minute has 60 seconds, so we can further refine our angles using minutes and seconds. And what we've got here, we've got an angle in degrees and minutes and seconds. Our minutes is this little apostrophe. The seconds is the quotation mark. So we're going to convert this from degrees and minutes and seconds into decimals, because that's useful when we're punching them in on the calculator. Now it is an easy transformation using the calculator. The first thing I'm going to do is rewrite this, and I'm going to imagine that degree sign is going to come down and turn into a decimal point. So that's going to be 85.1830. Now to convert this on the calculator, here's a TI-30. I'm I'm going to blow this up a little bit. Notice down by the equal sign and the plus sign. Right here above the equals is a DD to DMS. That is decimal degrees to degrees, minutes, and seconds. We don't want that one. We're going to use the one above it here, above the plus sign. So above the plus key, you see DMS, that's degrees, minutes, and seconds, will be converted to decimal degrees, DDs. So these in class are as easy as just punching them in the calculator. So you'll type in 85.1830, hit the second function key, hit the plus key, and out pops your answer. And that is going to be 85.3083. 3083. We usually go to 4 decimal places. Now think about it. 18 minutes is almost 20 minutes, and 20 minutes is 1/3 of an hour. So our decimal after the decimal point should be close to a 1/3 or 0.33. So here again is our answer in degrees and minutes and seconds, and here it is as a decimal. Now this next one, notice that it doesn't have any minutes. It's 330 degrees and 25 seconds. So we got to be careful. We are going to put a decimal right after the 330. So in our calculator, we will type in 330 point, but since there are no minutes there, we're going to put in 00 for the missing minutes. You know, those minutes need a placeholder. And then we will type in the 25 for the seconds. So if you type this into your calculator, hit the second function key, hit the plus key for the conversion, you get 330.0069 degrees. So there again, we're converting from degrees, minutes, and seconds into decimals. Now I think the next example is we convert in the reverse order. Here we go. So now we're given our angles in decimals, and we want to turn them into degrees and minutes and seconds. So these, we're going to do something very similar. Just type this in exactly as you see it. Second function equal sign is going to take it from decimal degrees to DMS, degrees, minutes, and seconds. Now, since you're doing this at home and you might not have a TI-30, we're going to do some of these in class, of course, when we're doing some odd problems. So this one here, if you type that in the calculator, press the buttons, the display will look like this: 0 degrees, 47 minutes, and 12 seconds. 12 seconds. Okay, let's look at this next one. It's 90.55, 90 degrees, and that 0.5, 0.5 is a half, so I would expect my minutes to be somewhere around 30 minutes, probably a little bit more. So we type this in the calculator, second function equals, bada boom, bada bing, out pops our angle. Now hold on a minute. I changed this in my notes. Yeah, we're going to change this on the fly. This one I'm not too thrilled with. In my notes, let's make this, and we're going to do a negative angle. Negative 30.355. So scratch that one out. Let's type this one in. We're going to type it again in the calculator. The negative sign is down here right next to the equals. So you type that in, you hit the convert key, and out pops negative 30 degrees, 21 minutes, and 18 seconds. Okay, so there we can convert and from degrees, minutes, and seconds to decimals, or vice versa. And that, I believe, is where the examples end. Yeah. So pause the video and try these team huddle exercises. Start the video back up and then see if you got them right. Ooh, and now that I think about it, these last two here, 28 and 32, these are conversions. If you don't have a calculator at home, let's make these our warm-up to start the class. So the first thing you do, you'll come in and solve those on a calculator, and those will be our warm-up questions. So I won't give you the answers in the video, but we'll get them in class for our warm-up questions. So I'm going to move these off here. We're not going to do those right now. Okay, and I guess the first one, we didn't do an example like this, but it's pretty simple. What quadrant does this lie in? Remember, any angle between 0 and 90, that's going to put you into quadrant 1. And then this one, I'm going to just draw a quick XY axis, and I'm going to count by 90 degrees. So if I go this far, it's a 90-degree angle, then it's 180, then it's 270, and I've gone too far because we want 257 and 30 minutes. So that's going to put us here in quad 3. Okay, the coterminal. Determine two coterminal angles, one positive and negative. Now, they didn't tell us to graph them, so we don't even have to do that. So let's see here. For 25A, our given angle is 300. So to find a positive coterminal, I'm just going to add another circle. And for my negative, I'm going to take the angle they gave me and subtract a circle. So let's see here, when we do this positive, if we add those together, we're going to get 660 degrees. That is coterminal with 300. And if we do the subtraction, 300 minus 360 is negative 60. And I'm going to just write the 300 in between them. So all of these angles are coterminal with each other. If we're at 300, we add a circle to get to this one. If we're at 300, we subtract a circle to get to the other. And we could keep going. There are infinitely many coterminal angles. You could keep adding 360 and get into the next coterminal. Now, when I look at B, I notice it's already bigger than one full circle. It's already beyond a full circle 360. So to get to a positive coterminal, we can actually just subtract. So here we are at our given angle 740. If we subtract 360, that's going to take us to 380. So here is a positive coterminal angle. And it looks like if we subtract another circle, another 360, we're still positive. So 20 is another positive coterminal angle. So they want us to get at least to a negative one. So here we are left off at 20. Let's subtract another 360. 20 minus 360 is negative 340. So there we found our first negative coterminal. We found a couple positives along the way as we were trying to get there. And again, I'll stop right there because these are going to be our warm-up questions when you come into class. Get your hands on a TI-30 and find those converted angles. Well, let's do this one too. An extra mastery problem. Because we're in trig and this is all new stuff, let's do one more of these. Find a positive and negative coterminal angle 4. Well, here's 65. If I graph 65, it's going to put me right about here, 65 degrees. I'll draw my angle to open up to it. Now I'm going to use blue for my positive coterminal. If I add 360, that's going to take me to 425 degrees. So if I start here, same initial, and I go all the way around an extra lap and stop there, that's my positive 425. And let's find a negative coterminal. If I'm at 65 and I subtract a circle, negative 360, that takes me to what? Negative 295. So I'm going to switch to black ink. And if I start here on my initial and go this way, clockwise, that is going to stop at the same terminal side. That's my negative 295. So we added a circle and subtracted a circle to get our coterminals. Negative 85. If I go this far, I've gone to negative 90, and that's a little too far. So this one is going to stop just shy of our negative y-axis. Here is our negative 85 degrees. Move that up there. So if I'm at negative 85 and I add 360, that takes us to 275. Why did I say 5 and write 0? 275. So if I open it up the other direction, the positive direction, I'm going to get here. That's 275. And notice, if we ignore the negative on the 85, if we just add the 85 and the 275, that should give us a full 360 circle. Okay, let's find a negative coterminal, and I'm just going to do this. If I erase that and make this into a minus sign, so now it's negative 85 minus 360. That takes us to negative 445. So I'm going to switch to blue ink for this one. Starting here on our initial side, we're going to go this way, but we're not going to stop at the terminal until after we've done another full lap. So that is more than a circle. That's our negative coterminal angle. Good times. That is the end of this video. Give the WebAssign a try. If you get it all done, that's great. And we'll be doing some odd problems in class to hopefully clear up any confusion. I hope the video helped.